Okay, hello, you welcome to my channel. All right, and now here with me is McKay, right? So McKay, say hi. Okay, McKay is my best friend, right? Good. Okay, today we are going to learn how to differentiate some natural exponential functions. All right, good. So I have here some basic examples for you. All right, good. They are all very simple, provided we have a tool. This tool is a master tool. It will help us solve all of this. Good. And the tool tells us that if you are given a function, okay, y given as e raised to the power g of x, right? So that little g of x there as a power shows that we're talking about the function of x in the numerator, right? Something written in terms of the variable x. Good. So to differentiate that function, we'll have the y dx to be, now this is what we have. The function, okay, which is in the power is what we are differentiating here, all right? So this right here is the derivative of that power, right? Okay, when we're done differentiating that power, whatever the power is, we multiply it with the whole function itself without touching it this time. So you just multiply it with this e to the power g of x, all right? Good. Okay, let's look at the first example and see what we have. We have there to be that y is e raised to the power of x squared. Good. So you want to differentiate that function with respect to x, okay? So I'm just going to put down the y, the x, to be, well, here, this tells us, so whenever we have a power, first of all, we will differentiate that power, right? So I'm just going to put down the derivative. This is the y dx. So I'm just going to put down the derivative of that power, which is x squared. Okay, we differentiate that with respect to x times, so the power is just x squared, and that's what I'm going to differentiate, all right? And then when I'm done differentiating, I'm going to multiply it with the whole function itself, all right? So I'm going to multiply it with e raised to the power x squared. Good. And now we have, well, the derivative of x squared with respect to x. Since this is just a power function, we're going to bring the 2 to the front, all right? So when I bring the 2 to the front, we're going to have 2 times, we multiply it with x, okay? And then we subtract 1 from that power, right? So I'm going to subtract 1 from that too. Good. And then we multiply it with, we just keep this one, all right, the way it is. We do not differentiate that anymore. Great. So here we are going to enter with 2 here, then times x. 2 minus 1 in the power just gives us 1, right? So that tells us that the derivative of x squared is just 2x, okay? Good. And then we multiply that with e to the power x squared. Okay, so all in all, that already is the derivative. So let me just rewrite it a little bit more. We have 2x, then e to the power x squared to be the derivative of that function e to the power x squared. So what you just need to see is that when you have the function, all right, differentiate the power is just x squared, all right? Differentiate that power, that will give us 2x, then you multiply it with the function itself, the whole function itself, e to the power x squared. Okay, good. Let's look at the second example real quick. And now as the second example, we have y to be e to the power square root of x. Good. This is not really different from the first example. All we need to do is this power here, this exponent, which is square root of x, we need to rewrite it in terms of power function, right? Taking note of the fact that square root of x is the same thing as x raised to the power 1/2. So I'm going to rewrite the function to be y to be e raised to the power of x. And this x here is the same thing as 1/2. This square root there is the same thing as power 1/2, all right? So this is not really different from the first one. Here, the power was 2, right? But right here, the power is just 1/2. Good. So we're just going to apply the same methods. We have the derivative of that function y with respect to x to be, well, we are going to have to differentiate this part, right? So I'm going to put down the derivative with respect to x of the power there, which is just x raised to the power 1/2, right? Times the whole function itself, all right? Our work here is just to differentiate the power, multiply with the whole function. So we have the whole function to be e raised to the power x raised to the power 1/2. Good. And then when we differentiate this, using the power rule, we just have to bring the power to the front. We bring this 1/2 to the front, that will become just 1/2. And then we put down the x, and then subtract 1 from this power, right? So this power is 1/2. We're going to subtract 1 from it. Good. And then we multiply it with this right here, which is just e to the power x, then x is raised to the power 1/2. Good. Then we're just going to have to do some subtraction of fractions there. 1/2 minus 1. Well, the result is going to be negative 1/2, right? So I'm going to put it down step by step. 1/2, then x raised to the power of 1/2 minus 1, as I said earlier, is negative 1/2. Then you multiply it with e raised to the power x, then x is raised to the power 1/2. Good. By applying some exponent rules on this term here, right? This is to the negative exponent. So because of that, it's going to come down to the denominator. So all in all, we are going to enter with 1/2. Then because of this power as a fraction, we're going to have square root of x. Good. Now, you just know that the derivative of square root of x, which is x raised to the power 1/2, is just 1/2 times square root of x, all right? That is a known result, so you just get the. Okay, great. So we multiply this with e to the power x, and then x is raised to the power 1/2. Anyway, since we started with the square root of x there, and this is still to the power 1/2, which is the same thing as square root of x, I would like to clean this up and then put down the square root of x, all right? Good. And this right here is the derivative of that given function. Great. Okay, let's go over and solve the third and the fourth question real quick. Okay, so here we have the third question, y equals to e to the power 4 minus x squared. Good. So let's go ahead and just differentiate this real quick. So we have the derivative with respect to x of y, right, to be, well, here we're going to differentiate the power, okay, as usual. So when we differentiate 4 with respect to x, we just have the 0, then put down the 0, then minus, we differentiate x squared with respect to x, we have 2x, right? Good. And then we multiply the whole result with the whole function itself, right? So the whole function is e to the power 4 minus x squared. Good. Maybe I can rewrite this a little bit. 0 minus something is going to be negative of that thing, all right? So we have here negative 2x minus 2x, and then we put down e to the power 4 minus x squared. And this right here is the derivative of that third function. Just differentiate the power, then multiply it with the original function. Great. Let's look at the fourth one real quick. So we have here to be y equals to e to the power 1/x, all right? Good. So the exponent is just a fraction. If you like, you can write it as the x root of e. But we do not want to go there. Like, this is very helpful. All we need to do is to rewrite this power here, 1/x, in terms of a power function. So I'm going to rewrite the function in general to be y equals to e raised to the power of, this 1/x is the same thing as x raised to the power negative 1, right? Just by exponent rules. Good. This negative 1 here will make the power here to become a fraction, just as it is. So we go ahead and take the derivative with respect to x of y, right? And that would mean, well, as always, we will differentiate this power, right? This is just a power, and the power is a power function. So we're going to differentiate that by, as always, we will have to bring this one to the front, right? That will become negative 1. Multiply it with x, then subtract 1 from this power, right? So we bring this to the front as it is, then we multiply it with the x, and we subtract 1 from the power, all right? Then we multiply everything there with the original function, which is just e raised to the power of x raised to the power negative 1, all right? Good. And then we're going to write everything to be, this is negative x raised to the power of negative 1 minus 1, that will give us negative 2, all right? Good. And then we multiply this with the original thing, which is just x raised to the power x, e raised to the power x, and that is raised to the power negative 1. Okay, great. I'm going to change this to a fraction. Since it has a negative exponent, it will become a denominator, all right? So you put down the x here. Good. And then since we have a negative 2 as a power, so this negative takes care of the fraction, makes it come down, and then the 2 is still the power of that variable there. And then since we do not have any other thing here apart from 1, I'm going to put the 1 here. Good. And then we multiply that with, well, this right here is the same thing as this, which is from the function we were given, all right? So I'm just going to write it as it was. Good. So this right here is the derivative of that fourth function. All we just needed to do is to differentiate the power and then multiply it with the original function. Okay, great. Okay, thanks for watching. Please subscribe to my channel.